Ever wondered was the next highest building to Godzilla here? Or have you ever wondered was the next highest apartment to your New York apartment? Yeah, let's see in this video. This is the video you have been waiting for a long time. Well, what we are talking about is monotonic stack. I bet you guys already know what is stack, but here we are going to discuss about monotonic stack. Let's move further. Enough for food cravings. Let's delve into the topic. So, if you have seen here, the man sitting on the left is a representation of Q, and the man who's vomiting on the right is a representation of stack. Just a refresher about what is stack. But we are mainly focusing on monotonic stack in this video. So you already know stack uses LIFO and which is last in first out, and Q means FIFO, which is first in first out. Let's start with an example here. So here you can see several superheroes: Batman, Spider-Man, Ant-Man, who is shortest of them all. And if you have watched Ben 10, then that's Webbig and Hulk. By looking at this, we can obviously say that Webbig is highest. But let's assume there are thousands of buildings. Finding it will be very difficult. But using monotonic stack, it's pretty easy. Let's see how to do that. What's our aim here is, let's just say we have Batman here. We need to find who's the next highest person to Batman, which is Webbig. And we have Spider-Man here, who's the next highest person, again Webbig. And we have Webbig here, who is the next highest person, no one. And same for Hulk as well. So these what we are going to find here, and to find it easily in a single pass, we are going to use monotonic stack. Let's see how to use this. So consider these superheroes as input, and their heights are as scaled here. So Ant-Man is the shortest, and Webbig is highest. Let's consider the indexes of the input. We need a stack because obviously we are going to discuss about stack, and a pointer at index, and consider this as a stack, and we have output array. So in this output array we are going to store who's the next highest person for a specific element at that particular index. So if we observe, there is Batman here at index 0. Who's the next highest person? Here at index 3, the next highest person is there. So we are going to store index 3 here. Well, let's move further. We have our stack, we have our output array, and we have our input. Currently the pointer is at 0, and we need to compare each element with the top of the stack. And if the element is lower than top of the stack, then we need to push the element. Otherwise, if the element is higher than top of the stack, we need to keep popping the elements of the stack until we find an element higher than current element on the stack. Well, let's see examples. We are at 0 here, and currently stack is empty, so we are going to push Batman into the stack. That's it. And let's move to Spider-Man here. Again, Spider-Man is less height than Batman. That means we are going to push Spider-Man as well. Let's push him. Let's move to Ant-Man, and Ant-Man is shorter, right? So of course we are comparing the element 1, which is Spider-Man, who is higher than Ant-Man. So we are going to push Ant-Man as well. Well, we got it. There are 3 elements in the stack currently, and Batman, Spider-Man, and Ant-Man are waiting in the stack. Let's move to Webbig. You can observe that he is the highest of all. So the people who are currently in stack, Ant-Man, Spider-Man, and Batman, he's higher than all of them. So what we are going to do, let's just compare the top of the stack. So Ant-Man is lesser height than Webbig. So we need to pop Ant-Man. And based on this, so you are popping Ant-Man when we encounter Webbig. That means the next highest person to Ant-Man is Webbig. So you just need to store that information at Ant-Man's index here in the output array. So let's just move forward. We are popping Ant-Man and storing the information here. So at Ant-Man's index, the next highest person is this way big. So we are storing way big's index. Again, we need to compare top of the stack, which is 1, who is Spider-Man, and way big. Right now, way big is higher than Spider-Man. So we need to pop Spider-Man and store the index of way big in the output array corresponding to Spider-Man. So we are going to do that. So we have popped it and stored the index here. Again, we have Batman on top of the stack. Again, Batman is way shorter than way big. So we need to pop again. Let's try popping it and store the index here. That's it. Now the stack is empty, and yeah, the stack is empty. So we just need to push the way big into the stack. Let's push him. Let's move Hulk. Obviously, Hulk is at the end, and he doesn't have any persons after him. It's going to be 0, but let's just follow the procedure. So we are going to compare Hulk with the top of the stack. Top of the stack is higher than Hulk, so we just need to push it. That's it. Our elements are done. So whatever elements are remaining in stack does mean that there are no greater elements after them. If you consider way big here, after way big there are no higher elements. So obviously it's going to be 0. We are going to store here because there is no next higher element. And if you consider Hulk as well, here after Hulk there are no elements at all, so it's also going to be 0. So whatever elements left in stack, their next higher elements won't be there, so that means we need to store 0 in output array. Yeah, that's all. You got it. This is what we call as monotonic stack. There are two kinds of monotonic stacks. The kind which we have discussed until now is monotonically decreasing stack. What is monotonically decreasing stack? If you observe, we keep on stacking elements into the stack. We stacked 0, 1 and 2 on top of each other, and they are following a specific height property. So 0 is higher. After that, one element which is on top of 0 element is shorter than 0, and 2 is even shorter than 1. You can see that these are of decreasing heights. That's why we are calling it as a monotonically decreasing stack. Even if we consider the last elements which we have pushed into the stack, so 3 is higher, and after that we have pushed 4 into the stack, which is of a lower size than 3. So that's why we call it as a monotonically decreasing stack. There is other variant of this as well. So this monotonically decreasing stack is very helpful to us when we are going to find next higher element. But if you want to find next smaller element, there is another way, that is monotonically increasing stack, which is very similar. These pyramids are representations of monotonically increasing stack and monotonically decreasing stack. Let's see what is what. The left pyramid we are seeing now is a monotonically decreasing stack. From the base to the top, the elements height keep on decreasing. So that's why it is called as monotonically decreasing stack, and it is mainly useful to find next highest element. The one on the right is actually monotonically increasing stack. From the base to the top, the elements height is keep on increasing. So that's why it is called as monotonically increasing stack, and this is mainly used to find the next smaller element. So you are basically need to maintain this monotonically increasing or decreasing property while doing calculations. Well, enough theory. Let's see the algo, how to implement this. This is the algorithm. First, we need to initialize empty stack and empty output array as we have seen previously. And after that, we need to loop through every element of the input, and for every element, if stack is already empty, then you should push the element into the stack. Otherwise, if stack is not empty and the current element you have accessed is higher than top of the stack, that means if you want to push this current element into the stack should also maintain monotonically decreasing property. But to maintain that property, we need to pop elements from the stack. So we are popping elements continuously from the stack, and after that, for this element which we have popped, the current element is what the next higher element, right? So we need to store that index in the output array so that we know the element. Let's just say previously we have popped Spider-Man when we have seen way big. That's why. So for Spider-Man, way big is the next highest element, right? That's what we are storing here. And after that, we need to push the element into the stack after popping all necessary elements. When the stack is empty, you just gotta push the element. Or when this property is not satisfying, Let's just say we have an element of height 5 and you are on top of stack and you are currently encountering an element of height 4 on the input. Then you just need to push the element into the stack. So now the element on top of the stack is height 4. Once you have looped through all the input, you just gotta return the output array. Let's just implement it in Java. Let's implement the monotonic stack. As you have seen in the algorithm, first we need to initialize output array along with the stack. Let's do that. And that output array should be of same size as input. Well, after that we need to initialize a stack. In Java in general we use deq-structure to implement a stack as well. Well, we need to loop through all the input elements, so we are doing that. After that, according to algorithm, while the stack is not empty and the height of the current element is greater than height of the element that is popped from the stack, yeah, that is on top of the stack, then we need to keep popping until we see an element that is more height than the current element on top of stack. So let's pop. We know the next highest element for the popped element that is current element, so we are just assigning that in the output array. After that you need to push as well, push the current element into the stack. So that's what we are doing here, push the current elements index to the stack. That's what we are doing. And finally after that, small typo here, and finally we are going to return output array. That's it. Most of the languages the code looks kind of similar. Well, that's it. And before going for a war on leet code, check out the description and please subscribe.